Hello, this is a quick video to announce that I have a new version of my Analog Discovery audio analyzer suite ready for download. I'm just gonna go through really quickly the features that have been added and the small changes and stuff like that. So the major change in the software is the tab here called Preamp Phono stage. So this comes from me wanting to be able to measure phono stages. So for example, here I have these little external phono stages, and what I noticed was that they sound quite different. So I was interested in finding out why do they sound different. So my preference was this one. This one sounded a little bit disconnected between the bass and the rest of the sound. So I thought it didn't sound like distortion. It sounds like a frequency response issue. So it would be nice to figure out whether is it caused by the equalization circuit, de-emphasize the phono equalization, or is it because of the input impedance, input capacitance, because that will affect the frequency response as well for phono cartridges. So I only tested with moving magnet. I don't use moving coil at the moment, but it shouldn't really make much of a difference other than moving coils got a much higher amplification. So typically for moving magnet, you would expect something like around 40 dB amplification would be ideal. So that has to be around at 1 kilohertz, because the equalization curve, it looks something like this, right? If we have the dB here, and then we have the frequency here. Right, so it looks something like this. The curve goes something, it's like a small kink here, and then it goes down. That is supposed to be flat. And here we have 1 kilohertz, and here we have 20 kilohertz, and here we have 20 hertz. Right, like that. So 20 kilohertz, it would be, if we say this is 0 dB, then this would be minus 20 dB, and this one would be plus 20 dB, plus the actual amplification. So if we say it's 40 dB here, we will have to add, so that would be 40 dB plus whatever we have here, so up to 60 dB. So 40 dB is like 100 times amplifications. That means that a 20 hertz tone would need to be amplified 1000 times. So 1 millivolt here becomes, at 20 hertz becomes 1 volt. Anyway, enough about that. Let's have a look at the feature. So the first part, so it's kind of split into two parts. This one here, impedance and capacitance, and that is to measure the input impedance and the input capacitance. Well, we can also use it to measure the output impedance of the phono preamp here, the same for this one over here. So in order for that to do that measurement, we need to have a small measurement jig. So I have one here. It's very simple. It looks like this. It just plugs into the Analog Discovery, and it's completely passive. Let me just show a thing. Yes, I have it here. Right, if we look at how it's connected, so we have the wave out, just the one channel. Then we have a 10 kilo ohm shunt resistor, and before the shunt, we just take directly into the input 1 and input 1 plus and input 1 minus, just connect to ground, and input 2 plus goes on the other side of the 10 kilo ohm. So this would be, over here we will have our phono stage or whatever we want to measure. It doesn't have to be a phono stage. You can also measure a preamplifier, but it's not really designed to measure like the output impedance of a power amplifier. For that, I have a different feature. So let's try run this and see what it does. So for this to work correctly, we need to calibrate it. That's because in order to measure the capacitance, we need to calibrate out the capacitance of the cable and the circuit itself, right? It's going to be capacitance, and we're going to have a piece of cable coming out here, going to the input. And since normally the standard for moving magnet cartridges is they usually say 47 kilo ohm input impedance and something around 100 to 200 picofarad, right? But that might change, and actually often the 100 picofarad is just going to be in 100 to 200. It's probably going to be in the cable going from your turntable all the way down to the input of your either your external amplifier, or maybe you have an integrated amplifier with a phono stage built in. So really, in most cases, the input here, we don't really want too much capacitance. Anyway, let's do a quick measurement. So to do the calibration, just take a cable here. So this is just a normal phono cable, and click the calibrate here. And then it says prepare for open calibration. So don't connect it to anything, just leave it like this, and then we let it do the open calibration. There we go. Okay, that's done. And then we want a shorted calibration. So here I just have it's just basically just shorted to ground, right? Just connect that here, and then we can do our shorter calibration. Right, there we go. So just a quick note on what the calibration result looks like here. So it should look like this. It should start up in the mega ohms, something in the mega ohms, and then you will just see like a gradual at some point here. It's going to start gradually falling. So what we're seeing here is just the noise that's kind of maximum it's able to measure. And then we have the capacitance in the cable, and in the circuit it starts here, right? So this is like measuring the impedance of a capacitor. And on the shorted, we have the resistance of the cable and the circuit, right? That's what we're measuring here in the beginning, and then at some point here it's going to start rising, and that is because of the inductance in the cable. So generally, if your calibration doesn't look like this, there's something wrong and you need to have a look at it. Okay, so we're done calibrating, so we can do an impedance measurement. So I'm gonna hook it up. Let's just do this one first. Do the right channel, and normally with the input impedance you don't usually don't need to power it up, but for it's really the right thing to do. So I'm just gonna connect power here as well to the amplifier. This is all we need, and then we just click impedance right, and then it should. Yeah, see, we start measuring here. So that looks fairly reasonable, right? So it's around 47 kilo ohms, and we get an input capacitance around 13 picofarad. That looks all good, right? No problems with that. And let's just do the other channel as well here, just to see if there's any major differences between the two channels. They both look very, very close. 13 picofarad, 15 picofarad. So yeah, I mean that looks just fine. And just for the sake of it, we can also do a measurement on the output impedance. So ideally, we should short the inputs when we do this, just to make sure we don't pick up any noise that's gonna affect the measurement here. So it does rely a little bit, I'm kind of relying on there being a capacitor coupling on the output here, so we don't have any DC on the output, and that's typically how you design it, right? So doing like this should work fine. And we do a measurement here, right? Wow, that's quite low output impedance. So it looks like a capacitor we see here in the beginning, and then this looks like it looks like they don't actually have a series resistor on the op amp for the output here. So we're probably measuring directly from the op amp output here, like 1 ohm. 1.7, 1.8 ohm output impedance. So that's a little bit funny design. Normally you put in a series resistor, something like 100 ohm or something, just because people are gonna short the output here, right? They're gonna connect the output to another output on the amplifier or something like that, right? Just to protect it. But anyway, I mean, it's not gonna have any effect on the functionality. Let's try the other one. Okay, it looks like they're fairly closely matched. No problems there. So that's kind of the impedance measurement here. We can do this one as well, but let's do that after we're done with this one. So that's it. So we can move on to the frequency response. For the frequency response measurement, we're gonna need another little measurement jig. So I have this one here. I made, so I just plug this one out. Generally, I would recommend building small jigs, something like this, just for more reliable measurements. I'm sure everyone who's got an analog discover got this kind of cable thing, and you could use a breadboard, but it's not going to give you reliable connections, and you're not going to get good measurements. I recommend take the time, build something. Maybe you can do something clever. You can combine multiple jigs into one and switch between them or something like that. But anyway, I just use these small ones here. Right, so we have this connected here. So again, we need to calibrate. So let me just go over this. I think I have a drawing of it here. Right, here we go. Very simple. Again, we just use one wave output here. I use a 47 kilo ohm resistor in series, and that is primarily to get some attenuation of the output. The reason I do that is because when we measure phono stages, we need really small voltages. So most are rated for, like, if you have a moving magnet cartridge, typically output is something like 5 millivolts at 1 kilohertz. So if we go back to, how's that? The first drawing here, right? So you can see if we have 5 millivolts at 1 kilohertz, that will give us 500 millivolts with 40 dB amplification, right? But it also means that at 20 hertz, in order to compensate for this curve here, we would have to send in 500 microvolts. And the analog discovery is not really designed to output really low voltages, so that is the reason it's a good idea to have a little bit of attenuation here. So that attenuation, of course, is going to be dependent on the input impedance we measured before, because the input impedance for the amplifier here might change depending on amplifier. For example, if you have a moving coil input, there typically the input impedance would be as low as 100 ohm. So that's quite a different situation. Anyway, we're measuring some moving magnet here. I follow up with a 47 nanofarad capacitor. So again, the capacitor is going to have to be matched to the impedance. If you have 100 ohm, then 47 nanofarad is much too small. You need to get up in the microfarads instead. And then we just do the two outputs, right and left. And the inputs again here is the same. Just put a small load on here, 47 kilo ohms. That's good if that matches the input impedance we're going to be measuring, because we're going to calibrate this circuit here. I'll just show it in a second. And anyway, it's going to the inputs here. The analog discovery itself, the input impedance is about 1 mega ohm. And it's a little bit high when you're measuring things. Normally you would expect something like 50 to 100 kilo ohms, maybe even lower on some measurements, right? So 47 kilo ohms if you're measuring moving magnet is a good value. Okay, so to calibrate this circuit here, because it's not going to be linear, right? We have a resistor here, and that's going to be affected by the input impedance, the input capacitance, and it's going to be the cable capacitance as well, right? So we're going to have something is going to, and this capacitor here is going to be, so we're going to have a response of this circuit is going to look something like this, right? So we need to calibrate that and compensate for attenuation. So we just connect, let's do the colors right. Find the other one here. There we go. So output to input, that's it. And then we just need to click calibrate over here, but because we're going to have a lot of attenuation, just going to increase the level here a bit to get a more accurate calibration. And then we just click calibrate, and off we go. Yeah, there we are. So that is the calibration, and well, you can see that we do have quite a lot of attenuation down at the low frequency, and then it flats out and it rolls off a little bit at the high frequencies. So that's going to be compensated once we start the actual measurement. So let's hook it up here. So we'll take the outputs here, put to the input here. And we're going to need some more cables, and these are a little bit unwieldy. Let's see if we can get this connected here. I could use some more flexible cables, but that's just what I had. Okay, there we have it. So it's connected up here. We're ready to do our measurement. So I'm going to set the level back. Let's start. It's a good starting point, 10 millivolts, and let's see what it looks like. Right. Yeah, so you see the frequency response here is not ideal. We have like 100 Hertz here. We have about 32.5 dB, and at 10 kilohertz, 20 kilohertz, we have 35.5 dB. So that's like 3 dB difference between the base and the up. So I mean that kind of corresponds with my feeling that there was some kind of disconnect. I have to admit I didn't actually hear the bass as being weaker. It's just kind of felt disconnected. But anyway, it's definitely not flat. The roll off here is kind of sensible. There's no problem in that, but the rest of it is definitely not flat. Anyway, we can see this frequency response here, and actually we could probably fix it. It's probably just due to when they manufacture these, maybe they change some component values to save a few cents or something like that, and they tested it and say, that's good enough. We could probably adjust it to give a flatter response, but it's not going to be in this video. Just one more comment here on the frequency response. So the reason I show the scope view over here is to give an indication so you can see if we're clipping. So if we increase the output here, let's say 30 milliwatt, and let's try run that again. Maybe it'll start clipping. No, it's not actually clipping. Not yet. Maybe we should try 50 milliwatt because the amplification is not that high on this one, 30-35 dB, right? Let's try set it to 50, then it'll probably start clipping. No. So it does support quite a margin. Let's try 100. I just want to show it clipping. There we see it. Start clipping. It's not 100% even here. Start clipping the negative before the positive, but it's probably just a virtual ground because it's a 12 volt input on it. But the reason is just to show that, hey, you might think that you're getting a fairly flat response here, but if you don't have the scope view, you might not be aware that it's actually clipping like crazy, right? So try not to make a clip when you do the measurement, and then it should be all good. It also gives the opportunity to kind of find out what is the maximum you can input, how much can it take. So because this is supplied by a small power supply, there's not going to be that much margin, but you could have other Phono amplifiers that can actually output some plus minus 20 volts or something like that. Not that you would ever use that, because that would be crazy, but it's interesting to see. Okay, I think that's all the measurements for this one. So we can just take a quick look at this one here. It's slightly higher quality Phono preamp, and it's actually got some configurable gain. So it's got like 2 sets of dip switches here, low, high, and combination of these gives us like 4 different gains. I think comes from like somewhere around 30 dB up to nearly 60 dB, and it also supports both moving magnet and moving coil, right? So you can set the input impedance from 74 kilo ohm and down to 74 ohm. So a bit more flexible, but of course also a bit more expensive. It's not that expensive though. It's like $100 something. So still fairly reasonable and reasonable quality. Anyway, let's do a measurement and see what it says. Just gonna get this one out of the way here. And let's switch back to the impedance measurement here. And go, so we don't need to calibrate it again, it's gonna be fine. We need some power as well. Let's see if I got this. Okay, switched on gas. We got power. Okay, so we got our impedance jig hooked up there and ready to do measurement. So I'm just gonna do this really quickly. Impedance right. Yeah, it looks like it's about 47 kilo ohms. Yeah, and the input capacitance is also very low, 17 picofarad and 16 picofarad. It might be off by a few picofarads. I mean, this is not meant as a super accurate measurement, but it is somewhere around this measurement here. That looks good. We can try the output impedance as well, just at least one of them here, and see if it looks different. Let's try this. Okay, yeah, that looks a little bit more sensible. So we probably have our coupling capacitor here, and then we go down to around 60, 70, maybe it's like a 68 ohm output resistor or something like that in after the op amp. So that kind of makes sense. So probably it's not going to happen anything if you short these outputs, or if you actually connect them to an input or an output on your amplifier or something like that. It's probably fairly well protected, and that's kind of the sensible thing to do. So just quickly to finish the measurement here, let's go back to the response measurement. There we go. Hook this up here. I'm not going to calibrate it again, but it's up to you. If you want to calibrate every time, it'll probably give the best measurement to calibrate. Anyway, here we go. So I expect the gain to be, I think this is the setting I use for it, and I believe this should be about 42 dB gain according to the manual for this amplifier here. So let's see if that corresponds to our measurement. That looks right. So let's go. I'll just set this to 10 millivolts. And here we go. Yeah, it looks like very close to 42 dB. And it's a fairly flat response here. We can see we go from 42.8 dB down, what is the lowest point here? Something like 42.2, 42.3. So it's like half a dB deviation across the whole audio spectrum. So that's quite good. And the shape of it is kind of like there's no radical change. It's like a soft change across here. The small dip we see here is probably some mains frequency noise playing with us here. It's around 50 Hertz. That makes sense. So yeah, that looks pretty good. And another thing that's important is that the two channels are fairly closely matched, and we can see here we don't have any there's no clipping at this voltage here, even though we can see it's like plus minus 2 volts coming out. So it's a little bit wobbly, but that's probably because the mains frequency noise that's going to affect the measurement a little bit, but that's still fine. So that's kind of it for this feature here. So I have the option here, so you can choose whether you want the compensation or not. Without a compensation, you can just measure the frequency response of a normal preamplifier, or you can also measure your integrated amplifier. The pre section, just take like a tape out or something and use that for your measurement. It might be interesting to see what the frequency response is like. You can also get an idea like what are your tone controls doing, things like that. So it should give some options. Yeah, I think that's it for this feature. Other than that, I made a couple of minor changes. If we go back here in GHD and noise versus frequency, one of the changes I made is here. So instead of having a drop down where you select the load, you can just enter whatever load you want here. There were some questions about could we add 1 ohm, could we add 5 ohm, something like that. So I just made it so you can just enter whatever value you want here. And the same on this tab here, whatever load you're using. I think that's it. No, wait, there's one more small change here. Intermodulation distortion, so you can do a combination of square and sine waves if it's something you want to play with. It gives some options to measure some different types of intermodulation distortion. Other than that, I believe that's it. If you have any questions, if you have any comments, if you have any feedback on using new features or any requests for other features, just let me know in the comments. I might not respond right away, but I will read them and I will respond eventually. Also, I changed the hosting for the files, so I think I'm going to add 2 links. So it's going to be either Dropbox and Google, I think, for sharing the files, because some people were having issues with the file sharing sites I was using last time. It seems like a simple solution, but it seems like when someone actually wants to download it, there are a lot of ads and misleading buttons, click here and click there. That's not going to give you what you want. So hopefully that should be done with. Other than that, thanks for watching, and I hope you find it useful, and I'll see you next time. Bye bye.